What if I told you that AI tools are not actually speeding you up, but making you slower? That's the finding of a recent paper that took off on Hacker News. It's called Measuring the Impact of AI on Experienced Open Source Developer Productivity, which is a hell of a title and does a great job of explaining the general study. So let's break it down. We conducted a randomized controlled trial, RCT, to understand how early 2025 AI tools affect the productivity of experienced open source developers working on their own repositories. So good, early 2025, so this is very recent. Surprisingly, we find that when developers use AI tools, they take 19% longer than without them. AI makes them slower. So a few things initially. So this is people working on their own repositories, so which may be relevant. We're not always working as developers on our own repositories. So these people are very familiar. They're in context, if you want to use LLM terms. They have a lot of in-context knowledge of the repositories. That may affect this whole thing in terms of them being better at doing things without AI. Then we've got this nice graph. So what we have is economic experts forecast, and on the vertical we have whether there is a speed up or a slow down. So economic experts were expecting a 50% to 30% speed up. ML experts forecast a little bit less, which makes sense because ML experts are more knowledgeable, a little less optimistic probably because they actually deal with the tools versus being business people. Developer forecasts during the study, developers expected around a 30% speed up, and on the low side, maybe 10%. After the study, they expected roughly the same range, and the observed result was a slowdown of up to 40%. So immediately, this is very interesting because even after the study, even after the observed results, we can see that developers did not update their thoughts on the tools. So they in objective reality, they move slower, and yet they still feel after using the tools that they were faster. So that's very interesting. Motivation. While coding agentic benchmarks have proven useful for understanding AI capabilities, they typically sacrifice realism for scale and efficiency. The tasks are self-contained, don't require prior context to understand, and use algorithmic evaluations that don't capture many important capabilities. I need to, at some point, look into these different things like SWE-bench, RE-bench. I know that it's certainly a widely used metric. I'm not sure how realistic it is. They're saying not very. These properties may lead benchmarks to overestimate AI capabilities. In the other direction, because benchmarks are run without live human interaction, models may fail to complete tasks despite making substantial progress because of small bottlenecks that human would fix during real usage. So this is saying it may get you 90% of the way, and then a human could easily just do the last 10%, but for a benchmark, this would probably just be marked as a failure. This could result in us underestimating model capabilities. Broadly, it can be difficult to translate benchmark scores to impact in the wild. I agree with this, and that's why what I tend to favor is I tend to like anything where it's kind of a blind taste test mode with an ELO system. So think like LM Arena, for example, is fantastic in this respect. What they'll do is they give you, for a given prompt, you might ask for like a sonnet or something like that, and then you'll get 2 answers. And you get to pick which answer you prefer. You don't know what model produced either one, and then they have a score, so based off a chess system, and models rise and fall quickly. So I also agree. It's very difficult to translate benchmark scores to impact in the wild, which is why I tend to favor user feedback more than anything else. One reason we're interested in evaluating AI's impact in the wild is to better understand AI's impact on AI R&D itself, which may pose significant risks. Not really sure what they're going for here. For example, extreme rapid AI progress could lead to breakdowns in oversight or safeguards. Measuring the impact of AI on software developer productivity gives complementary evidence to benchmarks as informative to AI. Yeah, okay, I don't really understand that. Methodology. To directly measure the real-world impact of AI tools on software development, we recruited 16 experienced developers from large open source repositories, averaging 22,000 stars and 1 million plus lines of code that they've contributed to for multiple years. Okay, so a couple thoughts here. First, a sample size of 16 is not very substantial, but I've already read through this, and one of the things I noticed was they paid the developers $150 an hour as compensation, which led to them paying $75K for this study. So it's understandable if they don't have the funding necessarily to scale this up. But what I would really like to see is I'd like to see more variety in terms of experience levels for developers. And just more developers total, because a sample size of 16 is really small. It's really important to note these are people who have spent multiple years on these repositories, so they know them very well, and these are very large repositories. So 1 million lines of code, I don't know what the typical real-world software project is. I don't know if there's such a definition, but the way I'm thinking about this right now, to avoid just going through and just doing lines of code measurements on different things I'm working on, is I don't like a file to go beyond about 150 to 200 lines of code. I think just at that point, you should be factoring things differently. And so if you have 200 lines per each file, and you were trying to figure out how big is a 1 million line plus code base, well, so 5 files gives you 1,000 lines potentially. So about 5,000 files that are as large as I think you should make a file. So pretty large code bases overall. Developers provide lists of real issues, 246 total, that would be valuable to the repository. So bug fixes, features, refactors that would allow them, that would normally be part of their regular work. Then we randomly assign each issue to either allow or disallow use of AI while working on it. When AI is allowed, they can use tools, Cursor Pro with Claude 3.5 or 3.7, which were frontier models at the time. When disallowed, they work without generative AI. They complete these tasks, which average about 2 hours each, while recording their own screens, then self-report the total implementation time they needed. Oh, that's very interesting. So presumably they don't have like a timer at the bottom, so they just have to go based off their feel. So that's probably where we get the huge discrepancy that we found, because they took longer than they felt. All right, let's see. So here we have kind of the methodology here. So we've got GitHub issues, we've got they had to do developer training, so setting up Cursor on the code base. Unclear if this is just saying this is an experienced developer. I guess that's what it's saying. 300 commits, 3 years of contributions. Then we've got 2 different paths. One where it's AI disallowed, AI allowed, calculate the time that was taken, and then we look at the different measurements. So the expert's forecast, the participant's forecast, their estimate after the fact, and what was observed. And they did some exit interviews. Okay, so when developers are allowed to use AI tools, they take 19% longer to complete the forecast, a significant slowdown that goes against developer beliefs and expert forecasts. This gap between perception and reality is striking. Developers expected AI to speed them up 24%, and even after experiencing the slowdown, they still believed AI had sped them up by 20%. Below we show the raw average developer forecasted times and the observed implementation times. We can clearly see the developers take substantially longer when they're allowed to use AI tools. Okay, so average developer forecast versus implementation time. So we can see the forecast when AI was disallowed was maybe about 1 hour and 50 minutes. And the forecast when AI was allowed was 1.5 hours. So people expected to save about 20 minutes per task. and the observed time when AI was disallowed was actually about an hour and 40 minutes, and the observed time when it was allowed was over 2 hours. So essentially we get the inverse of the expectation. So they expected to speed them up and actually slowed them down. Given both the importance of understanding AI capability risks and the diversity of perspectives on these topics, we feel it's important to forestall potential misunderstandings or overgeneralizations of our results. I think that's really important, and I think it's hard to do that. Like as a researcher, I'm going to put some kind of crazy clickbaity title, 100%. I'm going to say AI is slowing you down. And the reason is I'm looking for attention, I'm looking to get results out there. But in doing so, you sacrifice some of the validity of your research or of your findings because you're sensationalizing things. So I like what they're doing here. We do not provide evidence that AI systems do not currently speed up many or most software developers. So this gets into the sampling, where this is only 16 people that they've picked from. So they're saying we don't claim that our developers or repositories represent a majority or plurality of software dev work. AI systems do not speed up individuals or groups in software development, in domains other than software development. Okay, so they only study software dev. AI systems in the future will not speed up developers in our exact setting. Progress is difficult to predict, and there's been substantial AI progress over the last 5 years. Yeah, this is where it really gets to be tough because there has been tremendous progress. And so you look at what ChatGPT can even do, and we've had that for 3 years now, something like that. And it seemed like a future that would never come, to be honest with you. If you'd asked me when a computer would be able to pass the Turing test, I would have said 30 years, 40 years from now, maybe. And I think we can all say that ChatGPT can convincingly emulate a human, an expert. It's crazy what it can do. And so it's very easy to extrapolate. We had this big jump up. And it's easy to say, well, we're at the very beginning, and it's going to continue to just hockey stick straight up. And whether that's true or not is really only time will tell. So it's very hard to tamp down optimists because, yes, we have had substantial progress. All right, let's keep going here. So they believe these 5 factors are the most likely to contribute to the slowdown. So there might be an over-optimism about AI usefulness. Yeah, absolutely. Higher developer familiarity with repositories. Yes, so the fact that the developers are very used to these repos means, yeah, they're going to be able to do it better. Large and complex repos, again, we talked about this. When you have 1 million lines of code, all these LLMs, they have a fixed window size for their context window. And as a result, things may have to fall in and out of context. So think about this like your long-term memory. If you only have to remember a few small facts, it's very easy for you to hold that in your brain. And when somebody asks you for that fact, like how long is the Mississippi River? You can know that immediately. If you expected me to know every river in the world, I would have no idea. That would be an easy lookup, but if it's something you want in the back of my head, I can't do that. Low AI reliability. So this is interesting. Developers accept less than 44% of AI generations. The majority report making major changes to clean up AI code. Yes, I agree with that. That matches my own experience. I still, to this day, I cannot generate an OpenAI call using Cursor or Windsurf. Actually, I think I've only tried it with Windsurf recently, where it does not use the outdated version of the call. So let's try this quickly. Let's say create a new file called test.py where you make a call to GPT 3.5 Turbo. Should be quick. What I've found every time is it uses the outdated version of the API, and then you have to tell it, and then it's like, oh yeah, of course. So let's just see if this is still true. We'll create a key just for this. We'll invalidate the key afterwards. Good old reliable test. We will accept this, dump the key right there, and we will run this. What are we supposed to say? Say hello. Okay, sure. Oh, of course. There we go. So you tried to access OpenAI's chat completion, but this is no longer supported. Yeah. So still, to this day, it can't successfully implement this API, which is crazy. All right, let's now kill this later. Yeah, no, I'll do it now. Revoke. All right, so yes, low AI reliability. Okay, yeah, we get the feeling. So there were a number of comments that I thought were very useful in this. So first off, just a wide variance in terms of the results that people got. So a quarter saw increased performance, 3/4 saw decreased performance. Additionally, it seems like there's a learning curve, and I was kind of surprised. Most people in their study don't seem to have much experience with this. So we see a positive speed up for the one developer who has more than 50 hours of cursor experience. So it's plausible that there's a high skill ceiling for using cursor, such that developers with significant experience see positive speed up. I don't see this as significant experience. 50 hours is you work with this tool. I've done a work week with this tool. So this is another thing that, listen, I want to hate these tools as much as anybody else, but this seems flawed fundamentally. 56% had never used cursor before. Yeah. And then scrolling through, I think all of these discussions, they're dominated by a lot of emotionality around things. So on the one hand, you have people who are saying this is AI slop, this is AI shit, it's useless. And I think the Relentless podcast blitz by OpenAI and Anthropic founders suggests otherwise. They're both keen to confirm that yes, in 5 to 10 years, no one will have any jobs anymore. They're literally out there discussing a post-employment world like its inevitability. Yeah, so you have a very emotionally charged comment section here. So what's the true takeaway? I think it was well summarized by this comment here. I see this as a friction remover instead of a solution provider. The things that you can do rapidly in terms of both perception, fewer keystrokes, etc., is great. This is definitely, it's a fantastic tool. It's very good for quickly looking up or describing something. It's essentially doing a semantic search. You say, hey, I'd like to do a sort along these 3 dimensions of this list of objects, and it just writes your sort for you. That's fantastic. How long would that have taken me before? Well, when's the last time that I used, let's say, JavaScript's sort across different axes? I can remember when I used to work in Java, it would always be, if I return a value greater than, I think it was 0.5, does that mean that it sorts larger or smaller? And I could never remember the exact syntax. So all of a sudden, we have this really nice capability to look up all these diverse APIs, and rather than having to read through and look, let's look up Java sort. See if we can't find array sort. list. I feel like you were supposed to implement, or maybe it's, if you have an object. Yeah, if you have an object, then you can add sort order to it. This is going to drive me nuts. Hash. This is kind of what I'm talking about. I want to make my Java object sortable in a non-trivial way. How do? There we go. So there's the comparable interface, or you can have a custom comparator, and then I get examples here. So could I look this up? Absolutely I could, but you end up in this weird situation where people like to talk about there are only two hard problems in computer science, and one is naming things. Like, for me to remember over the course of time and different languages and everything else, comparable versus comparator versus, I know there's another way to sort here too, I just can't remember what it is a hell of a thing. So if I can have something where I can just describe at a high level and I can get results and I can get an example and do high numbers, return from compare, mean we place the object before or after. Just the ability to speak to the computer in normal language is incredible. All right, so I guess I should have known that. Negative makes sense. It would be less than, appear before, positive, greater than. Fantastic. But so the bottom line is, I think there's something here. Whether it's a replacement or not is a highly charged topic, but everyone should be using this. The fact that 56% of the participants in this study, they seem to be very serious software engineers, and yet they're not using Cursor or something similar enough to Cursor that they can just immediately drop in and use it, because Cursor is very similar to Windsurf, it's very similar to Copilot, etc. These are all just generic interfaces to an LLM now. That indicates that there's a lot of resistance and hesitancy to get into it, which is not the way that it should be, and I would encourage everybody to start looking at the tools. All right, so that was the paper. We're going to be doing this more often, and I hope people will join me.